thing. But why do people not use ensemble techniques in that case? So the greatest advantage, okay, first thing I'll talk about advantage. Advantage with respect to ensemble technique is that accuracy will be very high. Why do you think accuracy will be very high? Because you're running multiple times. First time when you run, algorithm might say person has cancer. Second time when you run, it might say no cancer. Third time it might say no cancer. Fourth time also no cancer. So you can always take that majority. Majority will not go wrong, right? If I ask a question to 100 people, out of 100 people, 80 people are giving me a specific answer. That will not go wrong because you're going with majority, simple. Right? That is another rationale why ensemble techniques give you good accuracy. Then why shouldn't I use that? Because of two reasons. One is it'll be time consuming process. If I run an algorithm one time, it might get completed in 1 second. If I run the same algorithm 10 times, it will be more than 1 second, right? Obviously. One algorithm, if I run once, it's getting completed in 1 second. In 1 second, I'm getting the result. If I run the algorithm 10 times, obviously the final result will not be displayed in 1 second. It will be more than 1 second. So it'll be time consuming. Second thing is, so let me remove these. Greatest advantage with ensemble technique or techniques is that accuracy will be high. Second thing is it will bring some stability into the algorithm because your accuracy values will not fluctuate a lot. Stability also will be high. However, what is the disadvantage? These are the pros. What are the cons? Time consuming. Absolutely, it will be time consuming, no doubt about that. Second thing is, if I run one decision tree, you can look at that rule, classification rule, which is this rule. Everything is a single rule, right? You can look at these rules and it is pretty self-explanatory, right? Income is medium and not a student and age is in between 31 to 40, person will buy a computer. So it is pretty self-explanatory. If I run hundreds of these models, then what will happen to your explainability or interpretation? It will become difficult. One algorithm, it's very straightforward. You're saying combine 10 such algorithms and 10 such classification rules, what will happen? Your interpretation will become difficult. So that's one disadvantage with interpretability decreases. These are the disadvantages. Okay, next. Okay, so next thing is with respect to the two steps. Here we didn't complete the two steps. One is either you build the same base learner or a different base learner. It's up to you. Once you build the model, how do you combine the results? Either using voting technique or averaging technique. Within voting, you have hard voting and soft voting. Hard voting means if for specific input, wherein you have age, gender, income, etc. And you want to classify whether a person will default or not. If you're giving these inputs to your model, okay, one decision tree model might say person will default. Another decision tree model might say person will not default. The third one might say person will not default. Fourth model also might say person will not default. Then what do you take out of all these? What should be the final answer? Not default. So you're doing a hard voting. Final output is dependent on the majority, maximum votes. Simple. Then you have soft voting. Soft voting is applied when you get probabilities as output. There's 90% probability that person will default. There's 84% probability that, or here, let me say there is 16% probability that person will default. That means there is 84% that person will not default. And here, if I say there's 90% probability that person will default, then what is the probability that person will not default? If I say there's 90% that person will default, what's the probability that person will not default? 10%. Here, say there is 90% probability that person will not default, 84% probability that person will not default, then probably 96% probability that person will not default. When you take all these, take an average. What do we get if we take an average? Anyone? Can you help me? %50%, is it? Let me say 20%. Then how much do you get? Sorry, 70%. There's 70% probability that person will not default. So what will be your ultimate result? Not default. Okay. So in that way, you just take average of all the probabilities and then take a decision on that. This soft voting can also be used when your output variable is continuous. What will be the salary of the people who submitted all the assignments, attended all the classes, worked on live projects, right? What will be the salary? One algorithm might say that salary would be 10 lakhs per annum. Another, algorithm might say salary will be 9 lakhs per annum. Another algorithm might say that salary would be 12 lakhs per annum. So ultimately, what do? You take an average of all these, and that would be the final salary. Okay, so that's called as soft voting. Hard voting is used usually when you have classification problems. Soft voting is used when you have output variable which is numerical. When output variable is numerical, the underlying problem is called as regression problem, friends. When your output variable is categorical, the problem is called as classification problem. Okay, classification problem or regression problem. Okay, voting is one thing. Then we also have averaging. One is simple average, another is weighted average. Usually averaging is used when you have regression problems. Regression problems means output variable is numerical in nature. Weighted average means give more weightage to those algorithms which give you high accuracy. Give less weightage to those algorithms which give you less accuracy. That's called as weighting average or weighted average technique. Okay. So what are the two steps in Ensemble techniques? You build various models and you combine the results, which is the second step. These are the two steps. Build different models, combine the results. These are the only two steps which are involved. So we now understand generative, non-generative. Within non-generative, we have voting and stacking. Within generative, we have boosting, bagging, and what else? Random forest. Okay. Then we have sampling techniques. So what we will do is we will We have probability, non-probability, cross-validation, bootstrapping. Okay. Then we will get into bagging. After bagging, we will get into random forest. I think until random forest, we will be able to complete. And tomorrow when we connect, we will be able to talk about boosting and stacking. With that, affirmatively, we should be able to conclude. Okay, these sampling techniques, let us talk about